woman who measured the universe. Sometimes the most unlikely people complete the most astonishing things. Most people believe that being a famous physicist requires being a genius. Everything else is just a simple side effect. It's not precisely like that, though. Undoubtedly, intelligence and brilliance are vital, but so are diligence and perseverance. It's not always simple to make important discoveries, and occasionally scientists spend years researching subjects that are ultimately fruitless. In certain other situations, people invest a lot of time in initiatives they won't see through to completion. Einstein, for instance, never saw the representation of a black hole. There is a tale that demonstrates all three facets admirably. The main character is undoubtedly the most unexpected, a deaf, modest American woman, the daughter of a Congregationalist preacher, who was put in charge of serving as a human calculator despite not deserving the status of an astronomer. Henrietta Swan Leavitt, the person who measured the universe, is one of the most significant female figures in the history of modern physics. Why is she so well known? What did she research? What made her a human calculator, exactly? Was the universe really measured by her? In what way? If you're intrigued, stick with me and get ready for this amazing voyage through the life of one of the most significant women of the 20th century. These and other questions will be answered in this movie. This introduction probably has you very perplexed, so let me to clarify things by providing a little explanation of what I just said. An American woman named Henrietta Leavitt worked at the Harvard Observatory to measure significant characteristics of hundreds of stars. Her calculations made it feasible to comprehend that a certain rule governs the illumination of some celestial bodies known as CEPHEIDS. Because of this connection, scientists were able to determine how to calculate the distance of thousands of stars in 1908, a feat that had previously been thought to be impossible. A really impressive outcome for a person who even lost her hearing and came from a lowly home. Let's tell the story of Henrietta based on this resume. Where did she originate? She was a Massachusetts native who studied at Radcliffe College, formerly known as Harvard Society for the Collegiate Instruction of Women. Her father was a Congregationalist preacher. She made the decision to attend Harvard Observatory after someone showed interest in her the previous year. She joined the Harvard faculty in 1898 and was named the institution's first curator of astronomical photographs. She then took 2 separate visits to Europe, during which she learned that she had hearing issues, which eventually caused her to go deaf. She returned to America in 1903 and was given a regular staff position working for Edward C. Pickering, whose main aim was to measure the brilliance of every star in existence. But why did Harvard start hiring women in the 20th century? It was uncommon to see a woman working at the time. Even among scientists, there was widespread discrimination against women, and they were not allowed to work as astronomers. According to this viewpoint, Pickering chose to hire women since they might be paid significantly less than men, especially in light of the shortage of funding for research. Because of this, more employees could be hired for the same budget, which was essential at the time because it was becoming increasingly difficult to process astronomical data quickly. In addition to Henrietta, Williamina Fleming, who was older, and Annie Jump Cannon, who was younger, were also appointed by Harvard. Because its primary function was to measure the brightness, location, and color of hundreds of stars, they were known as the computers. Pickering did not originally have to pay Leavitt because she had independent resources. Later, she was paid only 30 cents per hour or $10.50 per week for her efforts. She was apparently serious-minded, unselfish in her devotion to her family, faith, and job, and hardworking, seldom given to frivolous pleasures. Remember that although some of Pickering's female employees had degrees in astronomy, their pay was on par with that of unskilled laborers. They often made more than industry workers, but less than secretaries. For women, however, this wasn't an issue because they occasionally received permission to serve as volunteers for no pay in order to enter this field of study. Leavitt quickly moved up the ladder from regular tasks to the post of department director for photographic stellar photometry. She was then given the assignment of determining the star's radiation strength. We must first establish a few astronomical quantities in order to better comprehend the key accomplishments of this remarkable woman. You already know that brightness is a crucial factor when it comes to stars and galaxies. In astronomy, brightness is divided into two categories. The first is absolute brightness, which is a light-emitting object's radiation output. Take it into account as a measurement of its brightness. A lighthouse is more luminescent than a modest lamp. Additionally, we can define another number called apparent luminosity that comes from the first one. It is inversely proportional to square distance. In brief, perceived luminosity increases with increasing star distance and vice versa. A lamp has a larger seeming power than a lighthouse, even if the latter is undoubtedly brighter when placed 10 or 20 times farther away. There is a kind of surface density of power called apparent luminosity. Parallel to this, scientists defined apparent magnitude, which increases with decreasing luminosity and decreases with increasing luminosity. It can be compared to apparent luminance and is, obviously, depending on distance. Scientists have also proposed a new term for addiction, absolute magnitude. This term describes the magnitude that all stars would have at a distance of 10 parsec. Describe a parsec. The distance that results in a shift of 1 second of degree in the sky over the course of a year is measured in parsecs, or roughly 1,016 meters or 326 light years. Why are these numbers significant? Since they are connected by distance, we can determine the distance of stars if we know both of them. It is quite challenging to determine how far away the star is, which is a crucial aspect of astronomical research. Usually, astronomers attempt to determine a celestial body's absolute magnitude and determine its distance by comparing it to the apparent magnitude obtained through observations. Be sure to like or dislike the video before learning more about this so that we can keep improving and making these films better for you, the viewer. Additionally, be sure to click the bell to subscribe to the channel so that you don't miss any of our weekly videos. How is Henrietta's work connected to this? She was the first to discover a way to determine a star's absolute magnitude. Pickering assigned Henrietta to research the features of variable Cepheids, a class of star whose brilliance fluctuates over time after they finished their work on photometry. How did they find out about these heavenly bodies? Pickering and the computer users looked at different times at pictures of the same area of the sky. For instance, they looked at two photographs taken in November and February. One plate had a regular black sky with white stars, whereas the other had a negative sky with dark stars and a white background. The plates were then put together, and everything would have been neutral if the object's luminosities in the two photos hadn't changed because white and black cancel each other out. Henrietta noticed several brighter or darker dots on the plate and concluded they were variable Cepheid stars, which had a varying luminosity in the two photographs. This process was repeated in order to plot the luminosity variation over time. The members of the Harvard Observatory could see that these stars' periods were almost consistent. Henrietta, though, made a discovery that none of their coworkers could. She started researching the Magellanic Clouds, two hazy objects that were originally observed by Europeans in the 16th century in the spring of 1904. She came to understand that these celestial bodies were incredibly rich in diverse Cepheids. Because of this, she produced a study titled 1777 Variables in the Magellanic Cloud in 1908. She meticulously organized them all, displaying the various plates that were used to detect them. The most significant outcomes, however, can occasionally be obscured or challenging to spot right away, as is the case in this instance. Near the end, Henrietta added a straightforward and innocent thought, ideal for her modest demeanor, that was later used by other scientists to calculate the separation between hundreds of celestial bodies. Today, we can measure the universe metaphorically thanks to that term. After experiencing some domestic issues, Henrietta released a follow-up study in 1912 that provided additional evidence for the relationship between luminosity and time. What was the amazing outcome? It was possible to determine the distance of the Magellanic Cloud itself by assuming that all of these variables were at the same distance because they were all part of the Magellanic Cloud. It was feasible to determine the distance of stars and galaxies by watching the heartbeat in the luminosity of fluctuating Cepheids. This outcome was exceptional. The parallax was actually the sole technique available at the time for determining the distance between Earth and stars. This geometric process was based on the celestial body's angular displacement in the sky, which was brought on by Earth's rotation around the Sun. The displacement of the farthest objects in the sky was thus almost zero because this method had a size restriction and could only tell us about our neighbor stars. In order to be more specific, it is important to stress that Henrietta's discovery only provided the ratio between the distances of two separate Cepheids. A moment later, but why? The absolute magnitude of the two stars would be the same if their periodic variations were the same, but not their apparent magnitude. One's distance from another object is greater if it appears to have less brightness. Henrietta herself acknowledged the necessity of measuring a Cepheid's parallax in order to determine its distance and, subsequently, that of all other Cepheids with the same period. At first, it appeared that variables did not experience any angular displacement in the sky, but astronomers later created a new parallax based on the distance between the star and the Sun, which increased the size limit of this approach. With this method, Henrietta's luminosity period correlation could finally be used to calculate the separation between identical Cepheids. What happens at the end of this tale? At just 53 years old, the brilliant researcher from Massachusetts passed away in 1921 from stomach cancer. The progress of astronomy, astrophysics, and cosmology were all greatly aided by Leavitt's work. She was attempted to be nominated for the 1926 Nobel Prize in Physics by Magnus Gustaf of the Swedish Academy of Sciences, but as she had passed away, the Nobel Prizes are not given posthumously. The one I'm going to show is the most spectacular of the discoveries that have been discovered by utilizing this law, but the list is almost endless. Edwin Hubble measured the distances of Cepheids found in several nebulae in 1921 using Leavitt's link between a Cepheid's pulse rate and its brightness. He found that the Cepheids were beyond the Milky Way in terms of distance, that the nebulae were actually other galaxies, and that the universe was far larger than anyone had imagined and that it was expanding. Physics researchers later determined that the universe was expanding at an accelerated rate, always thanks to Henrietta's work. Because of how significant this finding is, it received the Nobel Prize. Here's where the video ends. Thank you everybody for watching. Are you intrigued by this subject? Are Henrietta Leavitt's accomplishments astounding to you? Did you know about her computations beforehand? Do you want to learn more about significant female figures in astronomy history? Have you ever read or heard anything about Henrietta? Please let me know in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.